Hey guys, so today we're going to talk about recursive rules, and all recursive rules are, it's just another way to write the terms of a sequence, okay? Like explicit rules is what we learned last time. Recursive now gives you, for instance, the rule right here, and then each a sub n is related to either the term before it or a term or two before it. Okay, if you notice here, my a sub n is going to be a sub n minus 1, which is the term before a sub n, okay, and then you add 3 to it, okay? So that's how recursive rules mean. It's kind of like you use the term before it to help you figure out what the next term is going to be, okay? Not my favorite, but whatever. It's part of what our curriculum states. So let's go ahead and write down the terms of a sequence. So if we have a sub 1 is 12, and then the recursive rule is a sub n minus 1 plus 3, if I want to find a sub 2, well, then I'm going to follow the rule. A sub 2, right, is going to equal a sub 2 minus 1. So what's a sub 2 minus 1? Well, that's a sub 1 plus 3, right? Which equals, well, what's a sub 1? So now you have to look at the term before it. A sub 1 is 12. So you write down 12 plus 3, and then that equals 15. All right, so now if you want a sub 3, that's going to equal, right, a sub 3 is going to equal a sub 3 minus 1 is a sub 2. Okay, well, what's a sub 2? We just found it. It's 15. So now it's going to be 15 plus 3. And so a sub 3 is equal to 18, okay? One of the problems I have with recursive rules is what if I said, hey, find a sub 100, okay? How would you find the 100th term unless you had the 99th term, okay? It's kind of, I don't know, not my favorite. I honestly don't know why we're spending time with this, but we are, so here we go. All right, so let's write some recursive rules, okay? So part B, write recursive rules. All right, and two that might be helpful are if it's an arithmetic. If it's an arithmetic sequence that you see, then a sub n is going to equal a sub n minus 1 plus d, and you know that d is the common difference, okay? And if it's a geometric sequence that you see, the a sub n is going to equal r times a sub n minus 1, okay? And r is the ratio, okay? All right, and sometimes you might not get arithmetic or geometric, but there will be a pattern, and I'll try to help you figure those out. All right, so here we go. I'll do 3 examples, maybe 4, okay? All right, so here we go. We have 3, 13, 23, 33, ... Okay? All right, so if you notice, the 13 minus 3 is 10, 23 minus 13 is 10, 33 minus 23 is 10. So it looks like our common difference is 10, okay? So this is arithmetic. So we're going to say that, and you have to do this. You have to state what the first term is, okay? So anytime we're doing recursive rules, you have to state that a sub 1, okay, is going to be whatever it is. It's 3, okay? And then you can go ahead and say that a sub n is going to be, and then you follow this. It's a sub n minus 1, okay? And then plus d, which in this case is 10. All right. Let's try another one. We have 16, 40, 100, 250, ... All right, if you notice, it doesn't go up. This goes up by what, 24? This goes up by 60. That goes up by 150. So it doesn't really work. It's not arithmetic, rather. So let's just see if it's geometric. Okay, let me get out of here. All right, so 40 divided by 16 is 2.5. 100 divided by 40, 2.5. Okay, so it's geometric. So my r equals, what did I say, 2.5. Okay, and so now it's pretty simple. Now you know it's geometric, so just follow this rule. First thing you need to do, though, is state what a sub 1 is, okay, and that's 16. And then you could say that a sub n is going to equal, whatever this is, the rate, which we said is 2.5, or the ratio, so 2.5 times a sub n minus 1, which is really times the term before it. So times a n minus 1, and that's that. Okay. Every now and then you'll get something funky like this. Let's try. We have 1, 1, 2, 3, 5, dot, dot, dot. Okay. Obviously the difference here is 0, the difference here is 1, the difference here is 1, the difference here is 2. It's not a common difference. 1 divided by 1 is 1, 2 divided by 1 is 2, so that's not a common ratio either, okay? But if you notice, there is a pattern. Watch this. 1 plus 2 is 3. Oh, 2 plus 3 is 5. Haha. So I bet the next term would be 3 plus 5 is 8. Okay, so I think we got it. Okay, so basically you add the two terms before to get the next term. Okay, so let's see where it starts. 1 plus 1 is 2. Okay, so this is the third term. So if this is the first term, second term, and third term, okay, we know that the first term plus the second term equals the third term. We know the second term plus the third term equals the fourth term. I think we're good to go, okay? First we have to state a sub 1 equals 1, okay? But in this case, we don't have to get the second term, we don't have a term before that. Remember, we have to add the two terms before it, okay? So in this case, we also have to state that a sub 2 is also 1, and now we can say that the third term is 1 plus the first term plus the second term. So now we can say that the nth term is going to be the term that's two terms before it, so that's going to be a sub n minus 2, right? Plus the term that's before it, so a sub n minus 1. Okay, and that's the rule for that guy. It's kind of funky, okay? Again, these are just kind of, if you're a nerd and you like to geek out on stuff like this is for you. Me, it makes my brain hurt. I'm not really into it, so. And if you're not, it's understandable. Let's do one more. We have time. Let's do this. 1, 1, 2, 6, 24, dot, dot, dot. Okay, and again, I like to put 1, 2, 3, 4, 5, okay? All right, so see if you notice a pattern. Okay. All right, I notice a pattern. I notice that 6 times 4 is 24. I notice that 2 times 3 is 6. I notice that 1 times 2 is 2. I notice that 1 times 1 is 1. Okay, so I'm going to play it safe because I really don't want to think about this too much, and I don't think you should either. But I'm just going to say I know that I have to state a sub 1, okay, and that equals 1, okay. And I may as well go ahead and state that a sub 2 is also 1, okay. I guess it doesn't hurt to, you know, to overkill, I guess. Nobody told me that I can't do that, so, okay. And so basically what I want, remember, I want a sub n, okay, and what that equals is, well, if you think about it, okay, how did we get this third term, right? The third term equals 2. Well, where did that 2 come from, okay? Well, it came from the term before it times the number of the term. Okay, so, right, 1 times 2 is 2, 2 times 3 is 6, okay? So, I'm going to try to do this without messing up, okay? So I know that, let's just say the third term. Say I want the third term, right? Isn't the third term, isn't it the term before it? So that's going to be the value of a sub n minus 1, right, times the number of the term before it, which is just n minus 1. Let's see if it works, okay? Let's try to do a sub 5, okay? And if it doesn't work, I'll crumple this up and we'll all take a break. All right, let's just do a sub 5 and see if it works, okay? So a sub 5 is going to be the term before it, right, which is 6, right? Okay, so that's going to be a sub 5 minus, right? 5 minus 1 is 4, the fourth term, which is 6. So it's going to be 6 times, and then it's n minus 1, right? So 5 minus 1 is 4, and 6 times 4 is 24, and the fifth term is 24, just like we said. Okay, so it works. It's just like, yeah, it kills your brain. All right, so let's do a couple more things. One last thing. Iterate a function. And I guess basically what that means is write the next terms, okay? So find the first 3 iterates, okay? All right, so here we go. Example. Whatever this means, we have f of x is equal to negative 3x plus 1 when x naught equals 2. Okay, and this is really straightforward. It's just plugging it in, okay? So watch this. This is how it works. Using a recursive rule, we want to find x sub 1. We want the first term, right? Well, that's going to equal f of x naught, okay? We're finding the iterates using the recursive rule, okay? All right, and well, what's that going to be? Well, f of x is negative 3x plus 1, so f of x naught is going to be negative 3x naught plus 1, okay? Which equals, remember, x naught is 2, so this is negative 3 times 2 plus 1, which is negative 6 plus 1 is negative 5. So there's the first iterate. Let's find the second iterate. That's going to be f of x sub 1, right? Which equals negative 3 times, well, what's x sub 1? Well, we just found it. It's negative 5, okay? Plus 1, which equals 15 plus 1 is 16, okay? And let's find the third iterate. And that's going to be, you guessed it, f of x sub 2, which equals negative 3 times 16, right? X sub 2 is 16, okay? Plus 1. That's negative 48 plus 1 is negative 47, and that's that, okay? All right, guys, if you want more help with anything, you know where I am, and I'll talk to you soon. Peace.